So what exactly is a trumpet mute? Well, a trumpet mute is an appliance that you put into the bell of the trumpet, and that changes the noise in varying different ways. So for anything, let's hear about the importance of these trumpet mutes from an expert himself.
Hi, I'm Gunnar Sergeant D'Ottaviano. I'm going to talk about the importance of playing on different mutes for any brass instrument, specifically trumpet. So straight mutes will create a little bit more of a zing sound. Cut mutes are going to mellow out the tone a little bit. Same thing, mostly used in contemporary jazz.
Mellowed out tone. That might be the most important thing that this person said regarding trumpet mutes. Now, the main goal is to change the sound, but also what I'm trying to figure out is how to get more of that mellowed out tone. So before we even start this process, I want to see what a normal trumpet sounds like compared to a regular mute on the trumpet. As you can tell from both of these videos, the normal mute doesn't really have that much of an effect on the overall sound and tone of the trumpet. Because of the lack of differences between both the trumpeted with the mute and the trumpet without the mute, I'm trying to figure out how we create that mellowed out tone. Now, for this, I will be using the calculus principle of related rates. You might be asking, why are you using related rates? Well, my hypothesis is if we change the airflow of the trumpet within the mute, then the tone will change. Airflow in itself can be measured using related rate principle, the air in, air out principle. If you take the measurements from the original trumpet mute that didn't have that much change, then we can measure out what the airflow is. So in order to use calculus to start off this whole entire process, I'll be using this equation. Now this is the volume of a cone. We first take the derivative with respect to time, which gives us this equation. Now we can finally start plugging in the values from our original trumpet mute to see what could be changed. After finding out the radius and the height, I calculated using the related rates problem to find the flow rate, which from this, as you can see, is 5.45 inches cubed per second. Given that the original mute is only about 6 inches cubed per second, we are trying to figure out what would happen if we increase the radius and the height of the trumpet mute and increase overall the flow rate of air. Will that lead to a different sound? In terms of creating my own trumpet mute, I want to increase the dimensions of the last one to create a greater airflow using related rates. Now, in terms of designing my own, I want to increase the measurements by 4/3. So in order to do this, I will change the original height of 6 inches from this mute to a new height of 8 inches. Along with this, I will change the radius from 2 inches to 2.67 inches. This mathematical process using related rates used the same process as before, but by changing each of the original values by 4/3. As you can see in my math equation here, the final value of the airflow rate if we increase it by 4/3 is 9.68 inches cubed per second. This should give us the basis of creating a different trumpet mute that sounds completely different with a different tone. In order to test whether my hypothesis was correct or not, I used a platform named Bamboo Studio. With this, I was able to design and input measurements that closely followed what a trumpet mute would be and how it would be applied to in a musical setting. After hours of designing and making sure my specifications were correct on the platform, I decided to 3D print overnight and took this time-lapse video to show my progress of my trumpet mute. We're done. After this whole entire process and the application of calculus principles such as related rates, we have finally come to our final trumpet mute. Now comparing it to the original one, this one's kind of small. But if we compare it to the 3D printed one, it pales in comparison to size. Now if we remember, the trumpet mute on the left had an airflow rate of 5.45 inches cubed per second. However, if we also remember the one on the right, airflow rate of 9.68 inches cubed per second. The final verdict is for us to test is which trumpet mute has a more mellowed out sound, the one on the left or the one on the right. Finally, the moment of truth, which trumpet mute sounds more mellowed out? Everybody, it's Rennie's Reviews back again. I am so thankful for you guys for watching my AP Calculus BC capstone project on trumpet mutes. At the end of this, it proved the hypothesis correct that if we did increase the airflow calculated using related rates, then it would change the trumpet mute sound to be more mellowed out. Thank you so much for watching.